Good morning and good afternoon, everyone. This is Andrea Baer. I am the Climate Services Program Manager in Western Region and your host today for the weeks 3 and 4 outlooks from the Climate Prediction Center. Today we have Jon Gottschalck. He is the Division Chief for the Operations Branch in or I guess branch chief in the Climate Prediction Center. And we're going to hold questions. We're going to let Jon get through his slides, and then we will hold questions. But if you have questions as we move through the webinar, just type them in the chat, and Jenna Myers is going to facilitate the question and answer session at the end. So thanks for joining us, everyone. And Jon, I will pass it over to you to talk about the week 3-4 outlooks.
All right, thanks very much, Andrea and Jenna, for organizing this and inviting me to speak on the topic Andrea mentioned. The title of the talk will be the week 3 and 4 outlooks that we're doing at the Climate Prediction Center. And I prepared the PowerPoint and will be given the webinar, but certainly want to acknowledge many staff at CPC that have contributed to the information, the data, some of the forecast guidance products, and ideas for the week 3 and 4 outlooks at CPC over the last several years for sure. There's too many really to list here. So I'll go on to the outline slide, and I hope I picked the right mix of material. I know some people may be new and not familiar with the outlooks, so I will spend a few slides on background overview of the products, but most of the talk will be on some of how we inform the outlook from a physical science basis to model guidance products and forecast tools. Considerable portion will be on some of the verification of our official outlooks, and then I'll wrap up with some additional information, which will include some ongoing work and plans that we have for the product moving forward. So for folks who are not familiar with CPC, there may be a few. Our mission at NCEP focuses more on the sub-seasonal to out to about 1 year or so, some variations on time scales from, say, the week 2 period, for example, all the way out to about a year, with the goal of trying to communicate and effectively manage and help people understand short-term climate prediction risk, whether it be from the monitoring point of view or prediction, as I just mentioned, to improve their situational awareness and hopefully to help make better decisions. We have both a domestic and an international presence, and there's just a number of examples of different products that we produced on that slide. We are in, many folks are obviously very familiar with this type of slide, seen the suite at the Weather Service. CPC, as you can see, fits in this 2-week the seasons realm. You know, a number of years ago, there was this gap in the official National Weather Service products in the week 3 and 4 time period that was starting to get more and more play and interest from stakeholders. We had a number of strategic planning meetings and stakeholder meetings back in the mid-2010s where this was made clear to us that we needed to move in this area. And so we actually first started targeting this after one of our strategic planning meetings to start to look at the week 3 and 4 time period to fill in that gap to some degree, based on feedback from you guys, both from the regions, WFOs, as well as other partners in the short-term climate prediction and monitoring community. And coincidentally, right after that, there was a big push by folks to the White House at that time for the Office of Science, Technology, and Policy from the DoD and from NOAA and the Weather Service that we needed to make this a high priority beginning as soon as possible. And so we had started this, so we were it fit very well with our plans and our objectives moving forward. And so we developed a working group during fiscal year 15, many years ago now, to develop these. And our first experimental week 3 and 4 temperature and precipitation outlook, which I'll show in a second here, was actually released on September 18, 2015. So it's been a while. And our temperature outlook became operational on May 19, 2017. The precipitation outlook currently remains experimental based on lower scale, we'll be at the point in the future, relatively near future, to start to consider steps to potentially make that operational, but that's going to take a longer process. And so that's something that we'll be thinking about moving forward over the next 2 or 3 years at least. So it will be a while if that does happen. And also important to mention is that this fits well into the goals and the objectives in the Weather Research and Forecasting Innovation Act of 2017, or the Weather Bill that many folks refer to it as. So the current outlooks, as they are produced now, are a 2-category outlook for either above or below normal 2-week mean temperature or 2-week total precipitation amounts, and the probabilities for those. And the white areas, as indicated here, are, since it's a 2-class outlook, 50% probability for each category. So in this particular example on the left, for instance, the odds of above normal temperatures, again, as defined by the mean, not the tercile limit, would be greater than 50%. Greater than 60-70% for the southern tier, the darker shading there, for example. And the blue shades indicate the elevated probabilities from the climatological value of 50% in the blue shades. And basically the same for precipitation, where above normal precipitation is in the green shades and below normal in the beige shades. Along with that outlook goes a pretty lengthy forecast discussion each week. These forecasts, as many of you know, are released once per week, currently due to some operational limitations of forecast guidance products that extend out to the weeks 3 and 4 period. But along with the maps is a overview forecast discussion of the physical basis for the outlook, what are the climate factors that are in play or not in play, and how they impact the outlook from a more phenomenological sort of basis. We certainly have a review of the dynamical model guidance. We also provide information as to where the greatest uncertainties are and the challenges for this particular forecast are, and a summary for both the temperature and the precipitation outlook, and some of the tools that we're using making the outlook. So sometimes additional information can be gleaned about our confidence and some of the challenges or concerns you might have with the outlook by reading the forecast discussion, text discussion here as an example. The physical science, the basis for the outlooks, and I think everyone would realize for the week 3 and 4 outlook period, it's a challenging period. There's a reason why this hasn't been tackled for quite a long time or ever, is that primarily you're no longer in this time range, you no longer benefit from some of the predictability due to initial atmospheric conditions, say that you may with the week 2, for example, 6 to 10 or 8 to 14 day. But you're also mainly in a range, not always, but mainly in a range also that may be too short to reliably benefit from some of the more slowly evolving parts of the climate system that we're more familiar with climate outlook, such as obviously the ENSO state, ocean conditions, land state, anomalous soil moisture conditions, for example, that can aid longer term timescale predictions, such as the monthly outlook, where you're averaging many weather events over 30 or 90 days in the case of the seasonal outlooks, where those slowly more evolving have more of a chance, more of an impact potentially on the eventual outcome of your temperature and precipitation observations. And so consequently, the week 3 and 4 time range, often suffers, not always, but can suffer from low predictability at times for sure. And it's important to understand this, that this is a limitation. We're learning more and more every day, but it's important to manage expectations for an outlook of this time range as compared to obviously the week 1 or even the week 2 period. So the factors that are considered at CPC and others doing outlooks or working in this area are some of the standard ones that people are very familiar with. The factors that are involved, obviously, ENSO from the background state point of view, like La Nina, El Nino in this particular case right now. Intraseasonal variability or subseasonal variability, the MJO is just one of those. There's other coherent types of variability in the tropics, for example, that at times can have similar impacts or interactions to the subtropics and mid-latitudes. The stratosphere plays a role. Obviously, we're familiar with potential sudden stratospheric warmings that can result in changes in the polar areas that can lead or result to potential periods of high latitude blocking events that have some persistence in the climate system for a few weeks that go into this week 3 and 4 period and impact indices that we're familiar with, the Arctic Oscillation, or AO, or the North Atlantic Oscillation, for example, and there's others, of course. The second grouping there are more boundary type conditions and trends. The first one, long-term trends, for example, how things have been behaving over the last 10 years or so, or 15 years compared to the 30-year average. Those can be used sparingly, but are used in this outlook too, because of the week 3 and 4 lead time. Soil moisture and snow cover anomalies, the snow water equivalent, for example, these sorts of things can help with feedbacks that have some memory in the climate atmosphere system, especially during the spring and summer months. And also at times, near coastal sea surface temperature anomalies can play a role in some of the more regional areas. A large basis for the outlook also is trying to encapsulate a lot of this variability from bias corrected and calibrated dynamical model guidance. We have a host of different various short-term climate prediction models that we use, and I'll go through some of those that are very helpful. And there's been a kind of an explosion of this area into the week 3 and 4 period over the last 5 years, which has been helpful to us. We have more information at our disposal to look at. And of course, empirical and statistical tools based on various climate variability linked to some of the main factors or types of variability and climate factors that I noted up at the top of this slide. So, just as a quick visual on this is, for example, the MGO, many of you are familiar with the MGO and the typical RMM phase diagram on the left. There's no need to go into details with this, but the idea of this particular figure is just to show we have predictions of MGO indices and other types of MGO-related variability or observations that we can predict into the future, whether it be through an index or through the actual potential teleconnections to the higher latitudes. And so we have this available to us for monitoring. One of the most powerful tools with the MGO is just monitoring that whether we have an MGO or not. And then the model predictions, therefore, both in a conterminous sense or a lag sense, can provide composite information and other statistical type or empirical type tools that show what the relationships are for temperature and precipitation over the U.S., CONUS, Hawaii, and Alaska, based on the MGO, whether it be, again, at the same time in certain phases or in the lag sense. Soil moisture, as indicated in this particular case by the U.S. Drought Monitor, can have very strong feedbacks, as I mentioned, on especially temperature across parts of the central part of the CONUS, for example. And on the right is an example. This is not the time of the year to be looking at this, but this is a vertical cross-section of the month of time on the x-axis and height, if you will, and pressure coordinates vertically. And we look at this to see how the stratosphere may be interacting with the troposphere when we have certain warmings, if you will. This is particular geopotential height, but you can also track temperature and heights where this may lead to changes in the Arctic Oscillation or poleward or pole type variability, which has, of course, impacts into storm tracks and other tangible weather elements at this sort of time lane. There's some lag in this particular parameter as well. So these are the features from a physical basis that we have in our mind that we assimilate as we go towards looking at the model guidance. And so as you can see on this slide, the first line is to kind of what I've been talking about is the first sort of box there, just assimilating what's going on. What's the forecast information on these major key climate forcing factors? Are they present or are they not? And predictions of those. We certainly have dynamical model forecasts that we use along with statistical tools. We combine those into our, where we create our probabilistic temperature and precipitation outlooks. As I mentioned, there's a forecast discussion with that. But an important part of a lot of this from a dynamical model point of view is this takes proper bias correction and calibration and later consolidation of multiple tools later on that is done that is indicated in that darker blue box there. It's all done prior to this, so the forecasters has the best possible information they can with respect to removing model bias, model drift, and properly calibrating for historical skill. Once this information is provided, there is a discussion at CPC 11:15 where forecasters and other partners get together to discuss some of this information, and then the forecaster will finalize the outlook, and then this is disseminated, as I mentioned, weekly, once per week on Friday, usually by about 3 p.m. or so Eastern time. And so there's a lot of information I went through there already about different types of information, but just to be specific, we currently have available to us dynamical model guidance that does extend out through the week 4 period from the CFS, the new extension from the Global Ensemble Forecast System, or GEFS, in recent years, the European Center Ensemble System, the Japan Meteorological Agency, or JMA Ensemble Systems, and also the Global Ensemble Prediction System from Environment and Climate Change Canada. So we have plenty of operational dynamical model guidance that we can utilize. We also utilize information from the Sub-X projects, which has a few additional models. What's key here is that there is a pretty rigorous bias correction and calibration process on these using model reforecasts, so that we feel like we have properly removed as much as we can of systematic errors in the model guidance, and try to link where we have the forecast model guidance has skill historically, when and what times of the year and what areas geography-wise. And then at the very end, we can do consolidation of different tools to help us boost skill where possible. So this slide is just kind of an example of some of the information that the forecasters would have, and this basically just shows we look at the hemispheric view because of all the different physiological factors or phenometrical factors that I mentioned earlier that are from the pole and from the tropics. So we look at the whole northern hemisphere, for example, and the tropical region. And these are just height anomalies for the week 3 and 4 period. We have this information, as you can see here, for a number of models for both week 3, week 4, and the combination of week 3 and 4. And these are reviewed by the forecaster and during that 11:15 a.m. discussion on Friday mornings Eastern time. We create blends. One is an auto blend, if you will, of the model guidance on the left, and we're working on an experimental manual blend to be a companion to our week 2 official 500 hectopascal height outlook that we released for the 6 to 10 day. And week 2 forecast, we're working on something like that for the week 3 and 4, week 3, week 4, and week 3 and 4, hopefully over the next year or so or less. We have information that's available. Again, these are internal forecast tools at the moment for a number of different variables. One, of course, here is calibrated. These are examples of calibrated probabilistic temperature forecasts. So we have anomalies for the forecaster. We have raw or bias corrected only probabilistic forecasts of temperature and precipitation for the forecaster, as well as calibrated, which is trying to make link of the adjustments for historical skill in various regions and times, as I mentioned before. And we also have objective combinations available for these. And that's similar for the precipitation. This is an example that's a little different. These are actually bias corrected and calibrated precipitation anomaly forecasts of the actual values. So there's a number of different pieces of information the forecaster will have available to them, as well as, in this case, for precipitation, the percent of normal for the 2-week period, things like that. For the statistical guidance, I mentioned consolidation here on the statistical tools, but it's the statistical handling of the weighting of the calibrated model guidance by the function of space, seasonal cycle or time of the year, things like that, and of course the particular model. But we also have more traditional multiple linear regression tools that I'll show in a second, as well as the constructed analog approach, which is a little different than a natural analog approach, where various EOFs are used from the historical record. This particular statistical tool is forced by 200 hectopascal stream function. The second one there, which is shown here on this slide, is a multiple linear regression where it tries to look at the various phenomena, if you will, to try to tease out the relative contributions of these modes in a more objective way. For example, this is a forecast that's older now from 2018, but it was a good example, which shows the contribution in temperature anomalies, in this particular case, for the MJO in the upper left, ENSO at this particular time in the upper right, and just regular longer-term trends. As I mentioned, that's another factor we use in the outlooks. And then on the right are the combination, but in probabilistic form, the probabilities. And you can see where various things are weighted in certain magnitudes to produce a combined forecast, trying to, in an objective way, combine all of this information into an outlook, into a guidance product that the forecaster can easily assimilate in their mind and to make use of, along with the other products that we have available. We make use of also blends with respect to the surface portions of the outlook, temperature and precipitation. Here, there's an example of a manual blend, if you will, where the percentages can be defined by the forecaster depending on how he feels those forecasts represent how he sees the system evolving over the next 2 to 4 weeks. Various percentages of the different models are shown there on the bottom center, as well as the multiple linear regression tool that I just showed. And so these are is a blend, if you will, manual blend, similar in ways to what we have for our official outlooks for the 6 to 10 and 8 to 14 day period. And so the maps can be derived from these, or they can be adjusted as necessary by the forecaster if deemed appropriate. Now moving into the verification portion of the outlook, have the next several slides look into how these outlooks have done. What's shown here is Heike school score for our temperature outlooks. Heike school score, if you're not familiar with it, is a hit-based metric where, in this particular case, for a 2-class system, 0 and negative numbers indicate no skill from a random forecast or a climatological forecast or any certain benchmark that you may want to choose, and positive numbers indicate positive that you have forecast skill or you're adding value to that random or climatological forecast. And the blue lines are the more noisy lines for the actual forecast over the last 7 years or so, from September 2015 to about July 1st of 2022. And the red dotted line is a 2-month running mean, or an 8 forecast average over that period. And so you could see a lot of variability even in that line. These are for the non-EC areas, so the coverage plays a role. But if you take a look overall, the forecast skill on average of all of these forecasts over the 7-year period is a positive 37.2, which is a good score. There's certainly cases that you can see where the blue lines go below the 0 line for no skill, and even times, including most recently earlier this year, where predictability really was a challenge, where the red dotted line, or even the 2-month running mean, went below the 0 line. There's only 2 times where that's really happened in the 7 years. But overall, the skill is positive for temperature during this period. For precipitation, I think everyone understands the challenge in precipitation from the short term all the way out to the seasonal time scale. It's very changeable in time and space, and is a difficult parameter to forecast at any time scale. First thing to note, obviously, is that the average over the whole period is positive, 11.1, but is significantly less, on the order of a quarter to a third, let's say, of that of temperature. And that's similar in many ways to some of our other forecasts as well. There's quite a bit of variability, and you can see there's more cases where the green actual forecast line of each individual week is below 0. But the running mean, if you will, 2-month running mean of red typically has been more above 0 than not. If you squint, you may see a little bit of improvement in the last part of the record, where we have a little bit of a little less negative values in the actual weekly scores. and where the running mean may be more tending to be more above the zero line. But it's a challenge, and we continue to work on it. This will be progress in this area with precipitation and with temperature, for that matter, will be incremental at this time scale. Taking a look now at where we have skill. This is a Heike skill map, spatial map for the whole period from September 2015 through July of 2022. Temperature on the left, precipitation on the right. Obviously the warm shades, yellow and oranges, reds, indicate positive skill, whereas the white has basically no skill, ranging from -5 to 5 for the Heike skill score, with the blue shades and purple shades indicating no skill as well. So with temperature, you can see overall, again, this is over the whole period, so there's variation, of course, within this, but generally positive skill for the whole domain for the most part. The highest skill for temperatures across parts of the Great Lakes and north and eastern seaboard, parts of the south and the west, and also for Alaska. There seems to be a local minimum in skill across parts of the plains and some of the high plains and foothills of the Rockies, especially in the north and also into parts of Texas. For precipitation on the right, obviously lower skill overall, as we see more white areas and also more blue grid boxes. These are mainly across the areas in which the variability is typically high, across the northern plains, Great Lakes, and into the Ohio Valley. As you can see, the areas in which we have no skill in those areas over the whole period. But there is also a large area of the forecast domain that does have appreciable positive or forecast skill for parts of southern and western Alaska, much of the west, parts of the southern tier of the U.S., and intermittent areas across parts of the interior of the country and northeast. When this slide breaks it down by seasons that we have for all the December, January, and February forecasts from 2016 to 2022, and from March, April, May in the same period on the left, and the summer months and the autumn months on the right, keeping in mind the differences in some of the years when we started doing the forecast. So first in the upper left, again, the skill scores are the same as far as color guide goes. Generally, good skill across much of the CONUS region in Alaska. There's some lower skill across parts of the Central Rockies and then some of the areas of the plains. But generally, the highest skill during the winter months has been at pretty high levels across much of the Great Lakes and Northeast and Mid-Atlantic. As we move into the spring months, Alaska and the West and parts of the Southeast have showed the highest skill, and due to variations, variable patterns in many areas across the upper Midwest, Great Lakes, and the plains, you can see there's a minimum in that area with no skill across parts of the central Mississippi Valley and central plains during the spring months. Again, just during this 7-year period. And then going up to in the upper right for the summer, again, generally return to positive skill temperature-wise for June, July, and August for mainly the west and the eastern seaboard of Alaska. Again, a local minimum in the interior part of the country. And for the fall, generally favored from the 2/3 of the eastern CONUS is generally where the best skill is. No skill across parts of the Pacific Northwest and Rockies, where Alaska has also more skill, mainly on the west and north coast. So those are seasons, but when you break it down, you see some of the differences with respect to with precipitation. I'm going to show the categories in a second, but this is the same sort of set of 4 maps for precipitation. Obviously, you can see more areas of white and blue in all of these seasons. You also see quite a bit of variability where we have forecast skill in these different seasons. During the winter, we have Alaska and parts of the southern tier of the U.S. and speckled in the interior is where we have positive skill. We do not do a good job in the northern plains, in the Great Lakes, and some of these other areas in the northern Rockies, for example, during the winter. For the spring, we tend to have better skill across parts of the west, even into the southwest. Those areas are very arid during certain parts of that period, but there is precipitation in March and also in parts of those regions, as well as in May in some of the eastern parts of the southwest. But again, if you look further east, the forecast skill considerably more variable. There's areas of positive skill, of course, in New England and parts of the Midwest, Western Corn Belt, but also just as many negative values or blue shading in other regions. Moving to the summer, there's a pretty notable area of weakness, likely where fronts are hung up, and there's variability in timing and location of boundaries, mean boundaries, talking about from the Eastern Rockies across the plains into the Great Lakes, but the southern tier and parts of the Northwest, positive skill. And for the fall, wrapping this up, generally more across the south central part of the CONUS is where we have the highest values, and we, again, for precipitation, struggle across the northern tier. Now, looking at this, we wanted to see, well, what about the categories? Do we have a bias one way or another? So the top row for temperature and precipitation is for the above normal category only, and the bottom row is for the below normal category only. And you can see some very interesting things. For above normal temperatures, that's where a lot of the skill comes from. For the southern part of the CONUS, you can see when we're looking at the below normal category, we do have positive skill on the northern tier, but some of the amplification and cold air outbreaks and cold air masses that penetrate into the southern areas, and especially in the southeast where we have no skill, at least with this particular metric and time period, is still outweighed by the positive skill we have for the above normal category when we look at all of the forecasts combined. So that's why the previous map I showed a few slides ago was generally all yellow, orange, and red. We had more of an influence from the above normal temperature forecast than we did for the below normal temperature forecast. We were working on this and trying to learn from, we think some of the amplification of the model guidance is causing this, and so we're trying to work on various techniques to help that situation. Now for precipitation, it's a similar story to some degree. For the above normal category, much of the forecast domain actually does show positive skill. Sorry for the area, and North Dakota seems to be the one area, as well as others in southern Alaska, that does not show skill. But similar to temperature, there is a bias towards our below normal category forecasts in the Midwest, Great Lakes, parts of the Ohio Valley. Again, we think that this is partly related to amplification downstream in the east central and eastern part of the CONUS that we may not be capturing from some of the model guidance and therefore underestimating in our forecasts. So there's a big difference in the precipitation for the below normal category, typically better across the West, less so across parts of the Great Lakes and eastern areas. So moving on to ongoing work to try to improve these forecasts, we have quite a bit of exploration, development, and application going on in the machine learning realm. I think many folks, many disciplines, and many parts of the Weather Service and the meteorological community or climate community are really, this is a hot topic, obviously. So we're working to use machine learning type methodologies for not only individual forecast tool development, but also to improve calibration methods and consolidation strategies to help try to increase our forecast skill, especially with precipitation. Other areas that we're trying to look at are trying to cluster or subsample dynamical model ensemble members or guidance, if you will, to focusing on a number of subsampling ones that we feel are producing higher skill at the start of the forecast period, and grouping those and basically trying to see if that type reduced ensemble member or reduced forecast tool ensemble, if you will, may produce more robustness at the start of the forecast and therefore may lead to a higher forecast skill for the eventual 2-week period starting at week 3 and 4. So there's a number of areas that are working in that region. Also, further developing the statistical approach through multiple linear regression in addition to the machine learning methods, targeting other climate variability, similar to a tool, for example, that I showed with the MGO, ENSO, and trend. We have others that target the Arctic oscillation blocking, things like that, to see if that gives us some additional forecast skill during certain regimes that we don't currently capture well, or the models don't currently capture well. So this whole area, there's quite a bit of ongoing development and research going on at CPC and with our partners. I wanted to shift gears here and talk about an additional information that we'll be providing at CPC. We have done this once, and we're in the process of organizing this with our partners and helpers at the Climate Service program managers and folks at the regional operations centers, and we thank them for working with us on this. Is that we're going to be trying to start preparing key messages similar to the other NCEP centers that WPC, NHC, and SPC, I believe, do regularly with certain high impact events. These, as I note here, are the impact focused. And CPC would, of course, coordinate and collaborate closely with the regions, as I mentioned, the ROCs, the regional CSPMs, and other partners, as well as the WFOs where possible. To start targeting, and I'll show an example of what we did for the first instance of this in a second. But we plan to start first where we have more ability, confidence, or reliability in some of the potential impacts with the shorter term, which will be the week 2 hazards outlook, denoting certain high risk events that we have in that outlook could be one reason for doing this. Also, moderate risk type events where the impacts could be favored due to regional conditions, ongoing drought or flooding or other sector sensitivities. We would potentially do this as well, and we would work closely with the regions, of course, on these matters. And we hope also to do, especially during the Northern Hemisphere autumn and winter seasons into the spring, trying to do messaging when we have sufficient confidence and reliability and a potential major pattern change from what we've been in that would span, that may occur in the week 2 to 4 period. That could result in change in operations or decisions that have been currently going in various sectors, whether it be the ag community, health, energy, or water resources. The information in this would be on our homepage for now under climate news, and also released on social media at or just after the forecast release. And the latency would be an issue we would definitely focus on, so that if there was any part of the forecast that was noted there in the key messages information, if any of that became invalid, it would be taken down from the homepage. So an example of what we did for an event, I guess a little over a month ago, was the extreme heat that was targeting parts of the central part of the country. The South Central Plains is where we kind of focused it here, and that was going to make drought conditions, rapid onset drought conditions, flash drought type activity across the South Central Plains more likely. We had various key messages of impacts, and some more details than would be available from the forecast maps that we released, timing information the best we could, and what the impacts could be in coordination with, in this particular case, the Central Region Operations Center. And there's on the right-hand side, some of the graphics that went along with this. And finally, last slide, just to summarize, CPC releases the weekly, week 3 and 4 probabilistic outlook for the odds of above normal or below normal 2-week mean temperature and 2-week total precipitation. The product begins to address, in some ways, a seamless sweep gap, and it aligns well with the strategy of the 2017 weather bill. We have considerable dynamical and statistical forecast guidance products available to us to inform the outlook, and forecast tool development remains ongoing, of course, in many areas at CPC and with partners and colleagues through competitive grant programs. And as far as the forecast skill that we all want to see improve, the temperature forecast skill is positive in most areas and seasons, but is limited by less skillful below normal category forecasts at the moment. Precipitation forecast skill is less in general, and that's not surprising for most areas and seasons, and also displays pretty large variability across various seasons and locations across the forecast domain, whether it be in Alaska or in the CONUS. So that's my last slide. I want to thank you for your attention and joining today, and I'll turn it back to you, Jenna, for any questions. Thank you.
Great. Thank you so much, John. Yes, we do have some questions that are coming in, but just as a reminder, if you have a question, please enter it in the chat box. Okay, John, so your first question is, will the graphics for the weeks 3-4 outlooks look similar in the future to the 6 to 10 and 8 to 14 day graphics?
Yes, we've made the change to those already. If I understand your question correctly, to the same legend design that we changed to the 6 to 10 and 8 to 14 day.
Okay. Next one is, in the above and below only high key skill scores you showed, they were from the full 2015 to 22 period. Do you have any like images from, say, just the most recent years that might show you've improved in the more recent years of the experiment?
That's a great question and a great idea. I don't have those. We can easily produce those. I don't have them here to show, but that's a great idea. That is something we can do. This is for the whole period, as you mentioned. There is some potential. In my view, I think we have improved in some areas with precipitation, as I tried to allude to in one of the slides. But I don't have those right now. But that's a good suggestion. Thank you.
Okay, the next question is, can you explain why the issuance date of the product is on a Friday afternoon?
Yes, the reason that was that certainly at the start of when we were doing this, we had limited dynamical model guidance that did extend into the week 3 and 4 time period. For example, the European Center forecast at one point only was released on Thursday. Also, the JMA forecast that we had, which is a model we had to reforecast for because we wouldn't be able to use the guidance without reforecast information. So that was only issued, and Environment Canada was only issued on Wednesdays. And so we would be using older information if we release the outlook, for example, on, say, Tuesday or Wednesday. We would have less information available to us. So that was the reason. However, in recent years, there has been an increase in the tempo, if you will, of some of the dynamical model guidance that does extend out into that period recently. So it does make it possible to potentially consider a second forecast in a given week, or potentially moving to a different day. But we haven't had those discussions yet. But that was the original reason. We really wanted to have some of the additional model guidance to us.
Okay, all right. Thank you for that. Next up is, considering the positive skill score plus 11 for precip forecast and the excellent skill shown in California and Texas for both above and below normal forecasts, why not push forward in making this operational? Is this, the precip? The precipitation is still experimental, right?
Yes.
Okay, so the question is, I guess, when will they be operational?
Well, at the time when we made the temperature outlook operational, we had discussions about that, and we and CPC and then others within the headquarters environment felt that was not sufficient to make up the product operational because of the lower skill. It's something that we will can consider again moving forward. One thing that we are working on is some of the social science information that we gained from various projects over the last several years. Was that one of the limitations in using some of our outlooks was that we had a variation in the different categories. For example, the week 3 and 4 outlook was 2 category versus 3 category for our other outlooks. And so it was deemed that a recommendation that we're considering would be to make the week 3 and 4 outlook also 3 category. This is something that we're working to evaluate now to see whether that's something that we want to do. It's probably only at that time that we would make the precipitation outlook operational. We wouldn't want to do it probably now if we decide to go to the 3 category outlook, which again, the earliest that would happen would be fiscal year 24 if it's deemed appropriate to do so. So that's one reason why in the near term we're not expecting to make the precip outlook operational right now.
Okay, thanks. I actually had the same question because I know we've been, and the next item is just a comment, because I was also surprised that we've been doing this for 7 years. Where the person said thanks. I was surprised to see that 7 years have already passed in the weeks 3 and 4 ever already. So I kind of made the same comment earlier today that I couldn't believe it had been 7 years already. So
Yeah.
I don't see any more questions. If anyone else has a question, just type it in the chat.
Yeah, Jenna, I do have a question that I often get from our field offices. I often get the Friday question. Why the Friday? That is one I get a lot. The other one is, so you update, CPC updates the 1 month outlook at the end of the month, and then of course they put it out on the 3rd Thursday. But has there ever been any thought to updating that weekly like the weeks 3 and 4 product?
Yes. We've had discussions, internally and in very early stages about, as I mentioned before, but potentially increasing the cadence for the week 3 and 4 outlook. But that's a resource issue that we haven't been able to address yet. But that is something that we have considered, increasing the cadence, meaning more than one forecast, so that there's a little bit more like an updating capacity, if you will,
Yeah.
which I think is what you're asking.
Yes.
So
Yes.
yeah, we are considering that, but that's a little ways away, I guess, because of resource issues, and we have to decide whether that's what we want to do. But that's good to hear that from you, that's a concern from your WFOs,
Yes.
because we do understand the problem with the Friday release. But again, at the time, it was more of a operational guidance limitation. But we are investigating ways around that.
Yeah, thanks. Yeah, those two are probably the 2 most common questions I get from our field offices in the West. So about this product.
Okay.
So thanks.
Yep. Thank you.
Okay, there was just a quick follow-up about being operational. Don't the NWS directives require that they go operational or be scrapped after 1 year of production? Looking at precip of this while asking.
I don't know if I can accurately comment on that. I'd have to. I don't know if that's the rule or not necessarily. I thought that was longer than that.
Yeah, I think it is. I'm not exactly sure either. I'm not a total expert on that, but we can look internally and
yeah, we can follow up on that. I mean, I agree that this has been experimental for a long time, but again, as I mentioned, the guidance we had was that we should, and you're involved in this, Jenna, obviously with just to make the temperature outlook
right.
operational. It's not like we're not going to continue to do the precipitation outlook. We would like it to make it operational, but we also want to make sure we do it responsibly. And as I mentioned, with the various projects that we have ongoing, we want to make sure, it might make more sense at that point if we decide to go to a change in the structure of the outlook. So we'll definitely understand the issue that's raised by the questioner there.
Yep. All right. Well, thank you for clarifying, John. I don't see any other questions coming in. Just as a quick reminder, we do record these webinars and we post it on the Climate Services Seminar Series webpage. I put the link in the chat box for everyone there. And thank you again, John, very much for today's webinar. Andrea, if you have any parting thoughts, I'll hand it over to you and then we can end it.
Nope, I do not. Just, yeah, like you said, thank you so much, John, for the information. Very much appreciate it.
Oh, you're welcome. Thanks for the invite. Appreciate it.
All right. Thank you, guys. Have a great day.